everyone, so for this session we are going to continue the discussion of agriculture, environment, and hunger. So for this session we are now already in limiting factors. Crops need around 20 chemical elements, adjust the right amount at the correct times and in the right proportions to each other. So these are essential factors in order for them to grow and develop. Now there are life important chemical elements which can be divided into two groups. One is the macronutrients and the other one is the micronutrients. Now macro, from the word itself macro, meaning to say big and huge. So these are essential chemicals necessary for all living organisms. Therefore, we could say that those living entities or the plants itself need this type of nutrients in a large amount in order for them to grow and develop. In the same manner, for micronutrients, these are essential chemicals necessary in small quantities, and they are an example of rare metals. So in order for plants to grow and develop, they need this type of nutrients in order for their growth and development in just a small quantities or small amount. Now, what are the examples for macronutrients and micronutrients? So we have sulfur, we have calcium, we have magnesium, we have nitrogen, we have potassium, we have oxygen, we have hydrogen, and we also have carbon. So this type of nutrients are needed in a large amount of plants for their growth and development. Micronutrients, example, we have copper, we have zinc, we have molybdenum, we have manganese, and we also have iron. These are rare metals and plants only need small quantities of these nutrients for their growth and development. Second, we have the pest and pesticides. Pest, these are the insects, and pesticides, these are the chemicals which is used to kill the pest. Now, pesticide, this is a general term for the chemicals that kills the pest, usually a toxic chemical, but sometimes we also consider chemicals that drive pest away from the pesticide. Some pest control compounds kill a wide range of living things, and these are known as the biocides. Herbicides are the chemicals that kill plants, insecticides are the one that kills the insects, and fungicides are the one that kills the fungi. The scientific industrial revolution of the pest control brought significant changes in agricultural pest control, which we can divide it into 4 stages. We have stage 1, stage 2, stage 3, and now we have stage 4 that somehow we are using this one because this is safe and effective. Now, stage 1, it refers to the broad spectrum in organic toxins. So what do we have in this stage? During the start of a modern science-based agriculture, the abundance of pests drove people to search for chemicals that would reduce their amount. The goal during this time was a magic bullet. This is a chemical referred to as a narrow-spectrum pesticide that would eliminate a single kind of pest and leave the rest unharmed. But this proved to be difficult because usually when they use chemicals, they do not only eliminate one type of pest. However, most likely they would eliminate all type of living entities, including those beneficial ones. Example of those very harmful toxic chemicals which is used during this stage is an arsenic. Now, arsenic was used as one of the previous pesticides, and they are very toxic, including to humans. They are considered as toxins, and they are very harmful not only for the plants, for the pest, as well as for the living things, or humanities, the living individual. It was useful in eliminating pests, but beneficial organisms went along with them. That's why it is considered as dangerous. Stage 2, these are the petroleum-based sprays and natural plant chemicals. Plant itself do have chemicals that help them eliminate pests. Now, from 1930s onwards, plants produce a natural pesticides that will serve as a defense mechanism against herbivores and diseases. Okay, this one here I will highlighted it. So the tobacco, for example, is an example of plant that produces a natural chemicals that help them to pest and other diseases. Tobacco plant produces a nicotine. This is an insecticide, and it is even used for today as a primary agent. Natural plant pest or natural plant pesticides are considered as safer among all the others, but in terms of, this is one of the disadvantage for the natural plant chemicals in terms of its effectiveness. Though it is safer, however, it is not effective compared to other insecticides. The third one, we have the artificial organic compounds. Artificial organic compounds have created a revolution in agriculture the moment it was introduced in the market, but they have significant drawbacks. So one problem is the secondary pest outbreaks, which occur after the extended use and possibly because of the pesticides prolonged used. Secondary pest outbreaks can come in two ways. Number one, please take note, we have the reduction of the target species cause the competing second species to flourish because of the lack of competition between the two species. And this will cause the second species to become a pest because there is already a competition among them for the resources. The second one, the pest develops resistance to pesticides through evolution and natural selection, which favor those who have more excellent immunity to chemical. Resistance has grown to many insecticides. So resistance cannot only refer to those microorganisms such as bacteria, where they show they could, what do you call this, they could resist medicines or drugs or certain drugs. However, as well as for other insects, they could also exhibit resistance against a pesticide. So in the long run, if you keep on using a certain brand or a certain chemicals to kill the pesticides in a long duration and a prolonged usage of these pesticides, those insects could develop resistance to that pesticides. So it's not good. Number 4, this is the stage 4, and this is what we know as the IPM, stands for Integrated Pest Management. Now, IPM uses a combination of biological control. Please take note, there are 3 combinations for the IPM. One is biological control, the second one is a use of a certain chemical pesticides, and the third one, methods of growing or planting crops. The key idea underlying the IPM is that the goal can be control rather than the complete elimination of the pest. So it is more on controlling rather than on eliminating. This course of action can be justified for several reasons. In economics, eliminating or even just a high percentage of pests becomes very expensive. In contrast, the value of a greater elimination becomes less and less in terms of the crops to sell. Now, in terms of biological control, the use is a natural enemy of the target pest to limit their growth. Caterpillars and other larvae pests can be combated with the use of bacterium in the name of Bacillus thuringiensis, or also known as the BT, which is very useful. And BT corn is already introduced. There are so many modified crops already introduced in the market. So we have BT corn. We also have the BT talong. So those are considered as genetically modified organisms where a certain type of bacteria, which is known as Bacillus thuringiensis, are incorporated in the plant itself, so that pesticides such as caterpillars or other larvae pest could not what do you call that, manifest, or could not go to the crops, or could not tawag niyan, they could no longer infest the crops. And then we have the types of pesticides. So what are those types of pesticides being used? So one way to classify pesticide are based according to their chemical structure and main components. So some are organic carbon-based compounds. So they are made up, these carbon base are made up, or they're one of their components are made up of carbon. Others are toxic metals such as the arsenic. Just like what I told you earlier, for the stage 1 they are very dangerous because they do not only eliminate harmful pests as well as the beneficial one. Or halogens such as the bromine. Now organophosphate, this is the first one. Actually, we have how many classifications? We have 6 classifications on the types of pesticides. So number 1, we have organophosphates. Organophosphates, these are among the most abundantly used synthetic pesticides. Glyphosate, this is a single heavily used pesticide in the United States, and it is also known as the trade name Roundup. I think you're familiar with Roundup. This is mostly common used by the farmers. Glyphosate is applied to 90% of US soybeans and other crops. Roundup ready soybeans and corn varieties genetically modified to tolerate glyphosate, while other plants in the field are destroyed. Most commonly planted genetically modified crops. Now the thing is, if you are planting genetically modified crops or GMC, then this type of crops can be destroyed by the glyphosate. However, for those crops such as soybeans and most common crops in the field, then they could tolerate glyphosate. So it's safe to use. They could only kill pesticides or pest. I'm sorry, these are pesticides. They could only kill pest. The second one, we have chlorinated hydrocarbons, or also known as the organochlorines. Organochlorines are highly toxic and persistent to sensitive organisms. In US, atrazine was heavily used herbicide was overtaken by the usage of the glyphosate. Corn crops in the US, around 96% are applied with atrazine to control the weeds in the cornfield. So usually this is used in the cornfield in the US to kill the weeds that might compete with the corn in terms of the resources such as water, sunlight, and many more. And then we have fumigants, the third one. So fumigants are generally small molecular compounds like ethylene dibromide, methylene bromide, and carbon tetrachloride. Those are the examples of fumigants. These compounds can be delivered in the form of gas for easy penetration into the soil and other materials. So fumigants are also used to control fungus in strawberry fields. So if you have strawberry farm, then you could use this one. They are being used, most likely they use this as their pesticide. And other low growing crops to prevent decay, rodent, and insect infestation in stored grain. And then we have inorganic pesticides. So these are the compounds made from toxic elements like sulfur, copper, arsenic, and mercury. These elements are considered as a broad spectrum poison because they are highly poisonous and indestructible. So which means they stay in the environment forever. So they usually act as a nerve toxins. I discussed this in our previous presentation. No, neurotoxins. So these are the examples: the sulfur, the copper, the arsenic, and the mercury. And they do not vanish in the environment. In fact, they will only stay in that specific area. So it's not good. It's dangerous. It's harmful. So historically, the primary pesticide applied to apples and other orchard crops were arsenic powder, but traces of the dust remain in the groundwater or soil in many agricultural areas. And then we have the natural organic pesticides. These are also known as botanicals kasi they are natural in comparison to the last one, which is inorganic pesticide. So they are the extract coming from the plants. So an example before was a nicotine and nicotine in tobacco, and nicotinoid alkaloids extracted from the tobacco, and pyrethrum extracted from chrysanthemum. This is what one of the species of a plant where you are going to extract this chemical which is known as the pyrethrum. So these compounds may also include turpentine, phenols, and other aromatic oils from the conifers. So these extracts are toxic to chemicals and may prevent wood decay, but it's not harmful to human beings. And then lastly, we have the microbial agents and biocontrol. Microbial agents and biological controls, they use living organisms or toxins extracted from them that they are used instead of pesticides. So a soil bacteria, just like what I gave as an example before for biological control, I under the IPM in stage 4. So we have the Bacillus thuringiensis. This is one of the chief pest control agent that allowed in organic farming. So when eaten, this bacterium targets the caterpillars and beetles and eliminates them by producing toxin that destroys their digestive tract lining. That's why they could kill those pests. Next, we have the food and nutrition. So in this case, despite the diet productions, that runaway population growth would soon lead to terrible famines because the number of the population increases globally every year. So of course we need to level up our food and natural resources so that everybody would suffice the needs of everyone. The world food supplies have more than kept up with the increasing human numbers over the past 2 centuries. The past 40 years have seen especially encouraging strides in reducing world hunger, and more than 850 million people today are considered as chronically hungry. Their diets don't provide 2,200 kilocalorie per day, which is deemed necessary for a healthy and productive individual. So one person could not meet up, or they could not achieve this 2,200 kilocalorie per day, which is very important in order for us to be healthy and productive. Poverty is the greatest threat to food security. Of course, if you do not have the money, you cannot buy food. If there would be no food in your table, so malnourished, of course, lacking of food. Now, food security occurs at multiple scales, and in the poorest country, hunger may affect nearly everyone, specifically those who are in the country, those who are living in the third world countries. Next, we have Green Revolution and genetic engineering. So around 50 years ago, agricultural research station started breeding tropical wheat and rice varieties to provide food for developing countries with a growing population. So from Mexico, this man here, named Norman Borlaug, from 1914 to 2009, he was able to develop one of the first miracle variations, a dwarf high-yielding grain. This is for the rice. Um, those people who are living in Asia are rice eaters, so we cannot live. Usually, we are rice dependent. So from morning, we have our breakfast, rice, afternoon, evening, not to mention we also have snacks and we eat rice. So around at the same period, the International Rice Institute in the Philippines, or also known as the IRI, also developed a dwarf rice strain produced 3 or 4 times more than the other varieties during that time. So this production of new types that caused a dramatic increase of yield was considered and known as the Green Revolution, wherein we produce a tantamount amount or varieties of grains. So it is one of the main reasons why food production was able to keep up with the rapid rise in the world population over the past decades. So can you imagine, without the Green Revolution, of course, famine is very common to everybody, not only in the third world country as well as the first world we encountered that one. However, since we discovered already many varieties of rice, many varieties of crops, we have genetically modified organisms for GMO, or we also have the GMC, genetically modified crops. So it could provide the needs of everybody. The Green Revolution varieties are considered as high responders because they yield more product if given the optimum water, fertilizers, and pesticides. So what does it mean? So given that they have water, pesticides, most common helpful pesticides, of course, and fertilizers, then therefore they could yield the optimum, what they call this, a larger amount of a product or the output. On the other hand, under suboptimum conditions, high responders may not produce as well as traditional varieties. Impoverished farmers cannot afford, this is one of the problem here in the Philippines, cannot afford expensive fertilizers or seeds and water to be part of the Green Revolution movement, and they become left behind. So this is all about the continuation for the discussion of agriculture, environment, and hunger.